Hello, everyone. I'm Elvis, and this is a new episode of the LLM News where we cover all the interesting and most exciting developments around the world of AI and large language models. First up, we have the major announcement from Anthropic on the Claude 3.5 Sonnet. And what they have announced is this new model, which they plan also to release the model family as well. So there's going to be 3.5 Haiku, I guess, and also they might have the Opus model. But this one is the Sonnet model. And what they're claiming here is that Sonnet is also very favorable in terms of cost, more cost efficient, but more intelligent than the previous Cloud 3 Sonnet model. And you can see Cloud 3 Opus here, one of the more expensive ones that they're offering all the way here on this chart. So this chart basically tells you intelligence versus cost. They do have a bunch of results that they're reporting here. So let's cover that quickly. And you can see that the Cloud 3.5 Sonnet is the most capable model that they have based on the results they're reporting on several common benchmarks like MMLU, human eval, and so forth. Big question is how does it compare to their previous best-in-class model, which is Cloud 3 Opus, and also GPT-4o. You can see the performances here. One thing that stands out with these results is the fact that GPT-4o is very capable in terms of these math word problem solving, right? You can see that by looking at the result on MMLU. You see this model is very comparable with the 3.5 Sonnet. On the math benchmark, you can see that this model significantly outperforms even 3.5 Sonnet. So this is a very capable model, right? And these models, what I'm seeing is that they have different strengths and capabilities and different weaknesses. One thing I really like about this announcement is the fact that these models also come with vision capabilities, and that really unlocks tons of applications and ways on how to use these large language models, right? With vision support, you can see that this model is one of the most capable models today. You can see how GPT-4o is very competitive as well based on these results. But for sure, 3.5 Sonnet seems to be more powerful than Cloud 3 Opus. And when you're looking at these results in these benchmarks, you have to ask yourself, question the results that you're seeing. I think it's worth experimenting. And on that note, I really like what Anthropic has done with this announcement. They actually announced a new feature called artifacts. It's a way to interact with these models and be able to generate these artifacts that could be like code. You could even design websites, generate code snippets, text documents, SVG, and so on. You can generate a lot of different things, and it generates right within the window where you're interacting with Cloud. That's really powerful. I've been testing it. I actually recorded a video. I will leave a link in the description so you can take a look at some of the examples that I've worked on. But here are just a few in a snapshot. So I generated this 8-bit style wire. This is pretty straightforward. I just prompt the model to generate it in 8-bit style. And this one is a very cool little game that I designed. So you can just collect a few coins, and I basically just prompted it. I didn't do any code, but you can actually see the code that it generated here as well. One thing I really like is you can generate presentations. So you can see this is a presentation that I generated as well. And lastly, I was working on this nice little project here where I'm interested to visualize the deep learning concepts, right? The linear regression. This one is an multi-layer perception. So I'm working on this project. I may have an update on this. I will probably release something in the future. But next up, we have this major announcement from Runway. So Runway is working on video generation technology. We have had a few video generation models that we have featured in the previous LLM news episodes. Models like Sora, models like the recent Kling, and Dream Machine as well as one of those. And Runway actually released a similar model where you can generate video. So you can check out the announcement here for more details, but basically they provide some examples on what these models can do. And from what I can tell here, the quality is pretty incredible. And these are 10-second clips. I'm not sure if it can generate more than 10 seconds, but they do provide a lot of like creative type of features where you can control better the scenes that the model is generating. So yeah, do check it out. There are more details here. There's no paper on this one. It's just some examples that they have announced. Next up, we have this announcement from Ilya Sutskever. Ilya is probably one of the brightest minds in the world of deep learning and has presented some of the, I think, most groundbreaking ideas in deep learning and AI in general. So everyone was really curious about what happened to Ilya, and there was even a meme going around. But finally, Ilya made an announcement, and he's announcing his new company called SSI Inc., Super Intelligence Inc., specifically Safe Super Intelligence Inc., right? This is a new company that they are creating. So you can see here, Safe Super Intelligence Inc. And they are describing what's the mission, the name, and the entire product roadmap. It's the sole focus of this team, right? And investors that they're putting together a specific initiative. And again, it's about safety, right? Ilya has been one of the biggest advocates, I think, for safety in AI. And I think this is one of the reasons why he might have left OpenAI in the first place, because I think OpenAI is slowly changing also their goals, and maybe that didn't really align with what he had in mind. And so everyone was super keen on what Ilya was going to do next. And Ilya is starting this company with Daniel Gross, which is a notorious also investor in the space, and Daniel Levy as well. So you can check that out. There's more details on their website. Next up, we have this release from Meta AI. They're always releasing cool stuff. And the reason why I really follow their work is because they're innovating on open source science, and they are releasing a set of models. So this is going to be Metafear, and they're releasing a bunch of models like Chameleon. We actually featured Chameleon in a previous episode of the LLM news, and they're releasing those, and they're going to make it easier for people to access it, like researchers, to better understand these vision models, these multi-model systems, also multi-token prediction. We did a video on this one as well. I might leave a link in the description for the video that I did on multi-token prediction, which is an excellent piece of work, and it's focusing also on scalability and making these models more efficient, especially these next token prediction models. And you can do so by doing multi-token prediction as opposed to the single next token prediction. So interesting work there. There's also more on music generation, right? There's speech generation as well, text to image generation. There's a couple of things that they have announced here, along with datasets and so forth. Very, very happy with what Meta is doing in this space. And next up, we have this paper. This is a technical report, and this includes the release of DeepSeek Coder. Now, I also did more extended video on this DeepSeek Coder version 2. So if you are interested in the explainer, I will also provide a link in the description. But I think this is probably one of the best open LLMs on coding and math. And they train basically on math and coding data. And they have a really powerful customized model that's great at these two tasks. And it can also understand instructions as well, can follow instructions, because it was trained to do a bit of that. They do report, however, that while they get state-of-the-art performance, is essentially competing with models like GPT-4 Turbo on benchmarks like Human Eval and Math, they still lack in terms of what they can do with the instruction following capabilities, right? So GPT-4 Turbo, we have this Claude 3.5 Sonnet model. They're pretty good at following instructions, but this model was customized, and I think in the process of training, right, it wasn't able to learn how to follow instructions really well. So that's something that they're working on and potentially improve, because I think that's really important, right? Because not every application is just about input of code and output of code, right? The formats are different, the modalities are different. Sometimes you may want to use this model in the context of an education application, for instance, where it's code and natural language, like explanation of the code. So it really depends, right? But I think it's still necessary to have that capability. This model is extended the context length from 16K to 128K. It also includes 16B and 236B billion parameter models, uses an additional 6 trillion tokens. I think total is over 10 trillion tokens that they use. They expand to 338 programming languages, a lot of programming languages. And so it's a good model. It's something to experiment with. Something they report also that this model is not so great on complex code generation tasks. Now, complex code generation would be like fixing bugs in a code base or finding something or generating unit tests or whatever that may be, which is also important, right, for a lot of applications that we build now today with these models. And that's not a capability that this model has yet, but I think because they're focusing on collecting better and better data, I think they're going to get at some point to be probably the best models on benchmarks like SW Bench, which is a very difficult benchmark from what I can tell. I also did a video on this memory tuning by Lamini. And this company is working on fine-tuned models and so on, but they presented this approach where they are reducing hallucinations by 10x and while keeping the accuracy of the LLM to 95%. That's incredible, right? And I think the hallucination part is really interesting in the approach they're proposing. So the way we usually reduce or mitigate hallucination is by sort of eliminating the assumptions that the model makes. That's one way. Also, we need to provide the model relevant context. And there are not a lot of great techniques to do that. A lot of people use RAG systems, but still there are conflicts that emerge when you are combining parametric knowledge with external knowledge with these models. So what's a better way to do this? And apparently they are presenting this method called memory tuning. And I've done a video on this already, so I'll provide the link in the description for you if you're interested to go into more details about what this method is. But basically, I'll give you kind of the summary here. It's using a bunch of memory experts, essentially, and combining those to come up with a model that can do this in an efficient way, right? Like memorize facts, and it's sort of like an index that you can leverage, right? When the model is doing inference or making those predictions of those tokens, you can leverage this huge index and can eliminate or reduce hallucination to some extent, right? And I think what they're reporting in terms of the metrics and performance, I think is amazing, because one thing also that happens when you mitigate certain things like hallucinations, you actually lose capabilities, right, with these models. And so it's important to also measure the quality, right? That the quality doesn't deteriorate. And so you want to keep both. And sometimes it's a trade-off, but they have figured out a method to do this really well, which is, I think, really impressive. Google DeepMind also introduced a new model, which is a model that can generate audio from video, right? So you may have videos that we're generating today. There's a lot of these video generation models, including the one that we talked about today with the Gen 3 Alpha from Runway, right? So these videos are generated, but they have no sound. So how can we convert those videos into videos that also have sound, right? Like when we're generating like a scene or a clip, we may want sound in these videos. And in fact, we do want sounds, right? Because we don't want to maybe use an external tool. We want them all to be able to perform that end to end. And so they've introduced something called video to audio. And I think it's one of the first models that achieve something like this. And I think the results are pretty impressive. The sound is definitely going to enrich that medium, right? That communication of this artifact, of this video. And so that's really important, right? Just generating the video is not enough. I think we need to be also focusing on this. So I'm glad that DeepMind is already ahead, and they're creating these models already that we can use to generate audio. That's really exciting, I think. And the way how this model works, they presented here, basically it's a diffusion model. They explain here that it takes video pixel and audio prompt input to generate an audio waveform synchronized to the underlying video. And V2A encodes the video and audio prompt input iteratively, runs it through the diffusion model, which is this one here. Then it generates compressed audio, which then is further processed by the decoder. Finally, we have this audio waveform. That's really cool. Doesn't look like a complex technique, but I think this is novel in itself, because I don't think there's a lot of companies doing this type of work where you're generating audio for video. So they have unlocked something here, and I'm excited about the research they're doing. This is an ongoing research, and they also kind of mention that they need to improve like lip synchronization. So where you have characters, right, you may want this lip synchronization when you see the character speak. And one thing they support, which is interesting, they support this positive prompt and negative prompt, which they do mention here, that can be used, right? So here, like the positive prompt can be used to guide the generated output towards desired sounds, Or you can provide also negative prompts. So these are not required, they're optional. The negative prompt can be used to guide away from undesired sounds. So it's similar to when you generate images, right? You can use these negative prompts as well to eliminate anything that you don't want in the image. Same applies for the audio. Next up, we have local tree. This local tree is from this team, the Open Interpreter team. They're doing a lot of like open source work, and they have really some really awesome tools that you can use locally. So you can use these models to like generate code. You can perform all sorts of things, the things that you can do with language models. And this is a massive effort, right? And they have a lot of integrations, especially with the Olama inference engine. They have some integrations where you can kind of set up or use these custom profiles for these open models like Llama 3, Moondream, which is for, I believe, image generation, and then Coastral, which is for code generation. So being able to use these locally, I think, is really powerful because it does enable you to do more, with your local machines, right? You may have a lot of data sitting around. You may want to do like some code generation locally or perform some task. And it's pretty useful. So I'm glad that we have efforts like this because this decentralizes basically the efforts and makes it accessible, right? Make all these models accessible in a way that we can use them and it's useful for us in our daily lives when we use our local machine, and really we don't need to access the internet to do all the amazing things that we can do with LLMs today. So do check out their efforts. There's a lot of links here that they're providing. Next up, we have Open-Sora. So again, this is about video generation. I tweeted about this as well. I work closely with this team. I collaborate with them, and they're doing some impressive work on Open-Sora. And this project is basically aiming to democratize efficient video production for everyone. And what they have released is the Open-Sora 1.2, which can generate up to 16-second videos. You can see the quality here. Keep in mind, this is open source, right? This is not a closed source model. The entire training code is provided. Everything is provided for you to reproduce if you want to reproduce and use it in whichever way or customize it whichever way you want. Really looking forward to what this team is building. And I think this only gets better. I mean, I think I saw like an announcement a couple of months or even a month ago about Open-Sora, and okay, this looks like an interesting toy project, but they've really innovated. You can see here, and they have really brought it so far to the point where this is absolutely really good quality already. This is a neat little tool for estimating or prices for up to 400 plus LLMs. And I can see from Agent Ops AI here that this is really useful, right? Especially now that we're working with these RAG systems and these long context LLMs and these agentic workflows. We need something to be able to calculate easily how much we're going to spend on these APIs or services or LLM services and providers that we use today. And I like the fact that there is like a tool, dedicated tool for this, right? That maybe we can trust and we can use to do estimates. Because I mean, I've seen a couple of tools here and there that companies have recommended, but I think having a tool like this that's open source, right, for the public and can allow us to easily use it without too much like abstractions or anything like that, just make it simple to use, I think is really powerful. Next up, I wanted to highlight this paper. I'm not going to go through all the details of this technical report, but I really wanted to highlight this particular research because there are a couple of papers that have been published in the recent weeks that try to combine like tree structures and LLMs to make them better at reasoning. So we want to solve reasoning with LLMs. They struggle to do advanced reasoning. And a line of work that I'm seeing is trying to combine LLMs with some external like tree structure or graph structure, because the graph structure allows you to more efficiently explore solutions, right? And make the model more robust and make the model more reliable as well. And so that's what they're working on here. It's called Monte Carlo tree self-refine. I guess it's mostly math reasoning, but still interesting. And these ideas of integrating LLMs with Monte Carlo tree search is not new. I think it is something that we're seeing more and more within the research field of AI. And so do check out the paper. I wanted to highlight it because there are a couple of papers already that have emerged, and I've featured some of them, by the way, in my previous LLM news episodes and my Twitter account as well. Next up, I have this context caching tutorial that I developed, and it's a feature from the Gemini team. So Gemini Flash, Gemini 1.5 Pro. This Gemini 1.5 Flash, you can combine this context caching. For instance, if you have like a really long document or something like that, and you want to like query that document or run a session on that document, that information without having to always pass that information as part of your prompt. And this is where context caching is really powerful. Now, there were some questions about pricing. I haven't done comparisons with pricing in terms of comparing context caching and just using the standalone, API calls with Gemini. I haven't done that analysis. I think I would want to do that analysis in terms of measuring latency, cost, and things like that. See if there are any other benefits that we're getting from context caching. Now, I think context caching as a feature is amazing because, again, you could provide a document, you could cache that information for as much time as you want, and they charge you, again, for storage. They also charge you for the time as well. And I think it's a powerful feature because it can support certain types of applications. And one of the applications that I tried in this tutorial that I shared on YouTube is basically going through like some ML paper summarizations that I've done over the last year and a half. And so I just wanted to do like quick analysis on those papers because I wanted to recall certain papers that I've even myself featured and I forgot. And so I think it's powerful. It enables certain types of applications. Do check it out. Next up, we have this new paper, and basically they do an analysis on these long context LLMs, right, on certain tasks like in-context retrieval and reasoning, but in the context of 1 million token types of tasks, right, tasks that require that amount of tokens. There's not a lot of problems where you would use that amount of tokens, right? If you're doing basic classification, for instance, or basic summarization, you don't need that. I'm imagining this is for more advanced type of tasks, but that maybe are more rare. And so the analysis is interesting because they are doing an analysis on capabilities and comparing to something like a retrieval system, right? Or a system that relies on some kind of retrieval component or external retrieval component, and even some solution that grabs an LLM and integrates that with like an SQL database or something like external database. And so what's the comparison here? Can these long context LLMs outpace, right, and outperform systems that integrate LLMs with external tools? That's really the big idea here. If we can, then why do we need to do this integration? But I think, in my opinion, we're not there yet. I'd like to see research like this because it does challenge the idea that we need to always use LLMs with some external tool. Maybe we could do the analysis and we can do retrieval with just the LLM alone, right? Everything passed into the context. But so far, I haven't seen enough evidence to indicate that this is the direction and this is what's working the best. I like the comparisons. I think the results are great. And they have done a wonderful report here. You can take a look, and you'll also kind of find what are the drawbacks. But one thing they do call out is that they are asking for more continued research around advanced prompting strategies. They think that's really important because they notice significant boost in performance when they apply these prompting strategies that they are suggesting in their paper for long context problems. So there's a couple of things that they mention in the paper which are really interesting. So one thing that they also call out here is that they suggest that compositional reasoning required in SQL-like tasks is still challenging for these LLMs. Again, you may think that you can just do everything with a long context LLM, but in fact, because of the way data is structured, right, I think certain types of data are not really fit for the type of analysis and capabilities that current LLMs have. And so that's something that I'm constantly monitoring, and I'm always talking about. Next up, we have this other paper from RAG to Rich Parameters. This investigates more closely how LLMs utilize external knowledge over parametric information for factual queries. As we know, when we use our RAG system, we're bringing this external information in, right? Is that always beneficial? The question is important to ask because it's not always beneficial. And what they find is that in a RAG pipeline, LLMs take a shortcut and display a strong bias towards utilizing only the contextual information to answer the question while relying minimally on their parametric memories. I've asked a lot of questions about this, and in fact, this is interesting research because this is how we understand better whether we could build really reliable RAG systems. I think these RAG systems are great. They do benefit situations like hallucination, where we want to mitigate that, for instance, but they also present issues and challenges where there is a knowledge conflict between the model itself and what the model knows and what you're passing in as external knowledge to the model via this retrieval mechanism. And so it's an important question, and I think I've seen a couple of papers now talking about this. I also featured this paper here that this person asked me, and this one includes more detailed analysis on the knowledge conflicts that are presented in LLMs when you combine them with some external database or information retrieval system. Next up, we have PlanRAG. This one enhances decision making with a new RAG technique called iterative plan, then RAG. So this one, the idea is that we want to combine this reasoning component together with the information retrieval system, right? And this is about leveraging the reasoning capability of the model and deeply integrate that into the whole RAG system. Because you can have a RAG system and you can do basic generation, right? And you're not doing like chain of thought, you're not doing any of that. I mean, essentially, what you're doing, you are ignoring what this model can do and its capabilities, right? And what this suggests is that we want to bring in more and integrate more deeply the capabilities of the language model as well together with this retriever system. So they do it in two steps. An LLM generates the plan for decision making, right? So this is intentional decision making that this model is doing, right? This planning by examining the data schema and questions. So it's again deeper integration, and they report really good results with this compared to like the standard iterative RAG systems, which a lot of people are already using. And so I think this is also a really interesting theme of research that's happening. And I'm excited about the results that they're presenting here, but there's a lot of papers that are emerging now where they are combining all of these like reasoning, tree structures, and all of these things together with the LLMs, right? And even in this case, with an information retrieval or data that you're getting from an external component. Lastly, I wanted to feature this. This is on Hacker News. Every now and then, I do see a lot of criticism around tools like LangChain and other types of LLM frameworks. And I think to some extent, I do believe this is healthy discussion in the community. I've been using some of these tools for like educational purposes. I've benefited from these communities. So I'm very careful not to say anything derogatory or negative. I do think, for instance, it's also important to disclose whether you have had challenges with LangChain and how you overcome them. And I think this is what this particular blog post talks about, right? What was the specific thing? Because I do hear a lot of people complain about tools like LangChain, but it's just a complaint, right? There's no substance there. And so when I see these complaints, I want to understand why, right? Is it because someone said so? Is it because you experimented with the tool and you found certain pain points? And I also understand how you overcame this. So with LLMs, something that I do mention in my course a lot, when people ask me, do you have any tools that you can recommend and so on, what I do tell them is that in a majority of cases with the clients that we work on these LLM projects, we end up implementing things from scratch. It's not that difficult, to be honest. Like if you look at LangChain and all the code base, there's like layers of abstractions, obviously, but the capabilities are like, okay, you have an LLM, you can generate this kind of agent, right? And you can combine tools and capabilities and so on. But all of that stuff is quite intuitive and very easy to implement yourself. And so I think this is what they're sharing here. This is the lesson learned when this team was trying to use LangChain to develop more complex agentic workflows. They hit a wall because it made it so hard for them, right? The way this tool is designed, right, it has these layers of abstractions, and it made it really hard for them to get any level of customization that they were looking for. They also mentioned here that how it impacted their development team, right? They got really slow at some point initially because they were just experimenting. It made sense to use a tool like this. In fact, that's one of the primary reasons why we use LangChain, actually, if we want to build a quick prototype. But when we want to put something into production or something more production ready, a lot of the cases we have code that we have implemented, functionalities that we have implemented ourselves that make it easier to extend on, right? And usually there's no like abstraction or anything like that. Usually there's like, okay, we are accessing a model, right? We have maybe some data processing that we're doing. We have these prompt templates that we have designed. And all of that like is just functions. Keep in mind that things are really changing fast in this space as well, right? So when you are committing to using a tool like this, right, like LangChain, do keep in mind, I think they make a lot of changes to their library and things break really fast. And so I always keep that in mind. I mean, like I said, have benefit from tools like LangChain. I think they have done excellent work in the community. What we refer to as agents today might not exist tomorrow. So I was going to this space, very skeptical about even the tools that you're using and the ideas as well. And so I think that's the lesson learned. That'll be it for this episode of the LLM News. Thank you again and have a good one.